Hello and welcome to everyone. You are watching Astonishing Zeta with Rudranil Sahu from Department of Mathematics, Burdwan Raj College. Today we will discuss about recently published research article in the International Research Journal of Engineering and Technology, aka IRJET, entitled on Exploring the Fitness Derivatives, Sine and Cosine, Enjoying Their Oscillation. So let's get started with a small quote of Clyde Tombaugh saying, can you imagine young people nowadays making start of trigonometry for the fun? Well, I did. So these are the contents part which we are going to discuss during this short lecture. It is divided into abstract, motivational research, introductory part, which is furthermore divided into basic discussions, early historical development and trigonometry, the basic preliminary parts, which is subdivided into trigonometry, differentiation of functions, some elementary results from the trigonometry, research objectives, research methodology, and then we come up to the discussion and analysis, notable results, conclusion, and future scope of our current research topic, which is divided into application of the concept and later and upcoming works. So let's get start with the abstract part, which is defined by brief research proposal and the summarization of the total work we are going to explore in this during whole lecture. Sine and cosine are the well known to be oscillatory functions. They are oscillating between -1 and +1 for all such values permissible in their usual domain. So here we introduce our proposal for the new conventions related to the hidden order of the derived functions. We are basically using here the elementary sines and cosines, and furthermore in studies we will explore the other trigonometrical functions like cosecant, secant, and uh, sine and cosecant, cosecant and secant, and tangent, etc. etc. In this article, we have developed very elementary level fundamentals to expand this field in this future. This study explores this relationship between higher order derivatives of sines and cosines. At the beginning, it seems fairly obvious, but it has underlying mysteries. Our methodology addresses new notations, which we have accepted to deliver our whole work, which we have delivered in this short PPT presentation. So basically, the we seek to unfold other properties of periodic functions like hidden beyond sine and cosines. So, what about the motivation of research part? During the time of 2020 2021, I have suddenly developed the concept of hidden order derivative without any kind of rigorous proof or any kind of rigorous calculation, you say. But I have made a rough idea of it by observing the relationship between sines and cosines and their derivatives. So, from the preliminary classes, we have already assumed they are very simple duo of sine and cosine are playing pivotal role in the whole trigonometry. And there lots of results exist with their relations. At a glance, it could be thought that Leibniz rule for differentiation is enough to explore this, but at the end of the discussion, we can feel the difference between the which I want to propose in my whole paper and which Leibniz want to propose in their own methodology. They are the both of them in a two different ways. So coming up to the introductory part, which is divided into basic discussions and early historical development of trigonometry. It is a very normal part, and we are going to just going through it. So trigonometry focuses on the interesting story of triangles and their corresponding arms and angles. The history of numerical relations of triangles found in ancient Egypt and Babylonia paved the way for the early trigonometry. In addition to Egypt, Babylonia and Greece made contributions to trigonometry. Indian mathematicians such as Aryabhatta I also performed many works on that topic. Trigonometric functions are easy to use, and sine and cosines are very useful in many fields of mathematics and physics and many real life applications. We can found their relations and their geometrical backbone in many kind of real life approaches. Like we can use their whole dilemma into the well known Fourier series. It depends upon the trigonometric representations such as sines and cosines. So coming up to the basic preliminary parts, which is subdivided into trigonometry, differentiation, and some elementary results from the previous calculus. So a real valued function f such that x to the y is said to be periodic function with a period t if that exists at least positive value t for which f of x plus t equals to fx. And for the least value of such t we can found and for which such kind of relation held, then we can say that the t is the principal period for the function we have taken. And geometrically speaking, every periodic function can be demonstrated over an interval of one period within the domain, as the same pattern will oscillate over the domain under consideration. And the sine and cosines are the basic oscillatory function which we know from our previous classes. So these are the rule for differentiation, which we already pretty much easy to explore, and we know already that f dash x equals to limit h tending to 0, which is occurring on f of x plus h minus fx by h equals to dy dx, where it denotes that the small change of y with respect to x, and we know that ddx of sin x equals to cos x and ddx of cos x equals to minus sin x. And these are the normal things we have just revised our previous classes. And these are some notations and some result we have already explored in our previous preliminary classes. And which is subdivided into research purposes, hidden necessity of hidden order derivatives, and why we choose the name hidden order derivative, and mainly the focusing areas in our research work. In this section, we have described the research purpose in details. With the newly adopted convention, we have derived few results in our later sections. Our objectives is as follows. In addition to their simple identities and the relations between sines and cosines can be extended furthermore. When we adopt the notations for differentiating sines and cosines, we explore the consequences of them, and a new branch of mathematics can be enhanced. Coming to the methodology part, and which is divided into defining the convention we have used and approach to the objectives we have already told. So functions are special kinds of relation between two non-void sets. Trigonometric functions are real valued functions. We define the sine and cosines in their domains as the real line, and the corresponding range is -1, +1, which is enclosed interval. And let us consider the sin x and cos x with the notations of fsx and fcx, and their nth derivative will denoted as fsx, and there is a small n with one small bracket in the top of it, and it is the superscript. And for the other, as we usually the same, and just we replace the s with the capital C for the cos functions. And we realize that the is a uh, very normal part to realize that fs4x equals to fs8x and fs12x and so on, fs4nx for any kind of multiple of 4 we choose. And similarly for the cos x function, which is related. And that's why we have taken the relation below. So for an example, in general example, apart from the sine and cos function, we have taken the x function, and which is the component function we call, like sin x and cos x are also the component function in the previous example. And so in that case, we can also define such kind of things, and these are the examples you can relate to them. So coming up to the discussion and analysis part, which we have discussed that the basic relation which we have occurred uh, in the last section, and on settling fsx equals to x0 denote the find function, and fcx equals to y0 denote the cos function. And coming up to the notable results, so these are some notable results you can check on it, and these are the very tiny relations we have found, and you can detail in detail can read the research paper I can give the link in description below. You can check on it. And these are some results we have followed, and like 8 to 9 results there are. So coming up to the conclusion part, by adopting this used notation used in this previous test section, we can derive many results, and from results of 8.1 to 8.9 addresses various results related to the differentiation of sines and cosines in the higher order. So we expect that the methodology used will help us explore the relationship among the different periodic functions rather than sines and cosines. In this case of exponential algebraic functions, we do not encounter any other kind of sufficient result to enlist. So in future, we can take any other functions to explore more in this field. So coming up to the future scope of our current research topic. So these are the applications of this concept and later upcoming works. So extending the methodology we have adopted here can be useful for settling possible relationship among higher order derivatives of different periodic functions like sine and cosine and like other plane trigonometry functions and other sine theta, cosine theta, and other sine function, cosine functions. So seeking the status of result when we replace the sine and cosine with the other trigonometric functions and finding the consequent of geometrical backbone the obtained result. It will be much more exploring and much more thrilling to kind of exploration. Let's see what happens in future. Let's see. Let's hope that you enjoy this lecture. And these are some useful references I have followed during this making process of PPT presentation. And thank you for watching. Till then, keep watching and keep supporting us. And hit the bell icon for get the new notifications on your screen on YouTube. So thank you for watching.